Hi, this is an introductory topic to forecasting. I can see forecasting everywhere. You can see it, for instance, in the trees when you are walking in the park. You will see that trees have their own strategy to survive, so they have to have certain strategies to like have like an existence or like coexistence with the rest of the environment. So in doing that, they forecast, for instance, every organism forecasts what is going to develop in order to survive. So human beings, we have developed this faculty of having brains in order to understand and to be at the top of the hierarchy, supposedly at the top, because sometimes there are other species that probably affect us. I'm not sure at what extent, for instance, viruses can be the future, but anyway, we have strategies, and we use forecasting in order to nature use forecasting as well in order to get to know what are the strategies that are going to be prevalent and are going to be more successful. So let's go quickly to my slides and let's conduct a very quick introduction to forecasting. So we start here. This is the handbook. Why forecast? Forecasting is almost everywhere. So any rational or living thing that has certain logic use forecasting in order to survive. Everything has a logic as well, like planets and everything, animals, the weather. So forecast is actually very important for economics. So for instance, if you go to the OBR, you will see that forecasting is one of the most important attributes. They need to forecast and to carry on doing forecasting to, in a way, monitor what the government is doing. Yes. So the government as well need forecastings in order to get to know if, for instance, Brexit is going to be good for the economy or for a certain sector of the economy. They use it to get to know how to make policies in order to solve the crisis that we have, etc. So forecasting is almost everywhere and is actually one of the most important tasks of any economist. We particularly focus on fundamentals, financial markets, for instance, as well, bond markets, the money market in general, equity markets, bond markets, foreign exchange rates, now the crypto space, everything, and forecasting is almost everywhere. Right, so forecasting is to predict the future value of a time series. So we use time series to forecast, and they are almost everywhere. For instance, IBM probably did not forecast that their computer was going to be like everywhere for everyone. So here you have Thomas Watson. He believed or thought that his computers were going to be just for only five persons in the world. You can see here more examples of that. Here is the source in the urbanization econometrics model. So you can see how they predict the population growth in China and in India. Very important as well, research. We want to know, we use these forecasts in order to get to know what is going to be the growth or the growth in income for people and how sustainable the world is. We have as well that is almost forecasting is everywhere in transportation, retail, weather, tourism, financial markets, economic indicators, demographics, everywhere. You use as well forecasting everywhere, every time that you try to engage in certain activities, so you forecast your time without knowing, for instance, the time you spend in studying, the time that you spend in having a holiday, because you want actually to get the most from every activity that you do. So these calculations can be more formal if you want, and can make very complex forecasts, such as in this business is totally automated, so you can see just only robots on these slides, and these passing bands are making all these boxes to send deliveries everywhere. So this is a very automated, actually, robot, a very big robot that takes the products and takes them directly to the lorries and send them everywhere. Yes, so I think is this somehow what we want to do with economics in this module. Yes, automated codes, automated algos, and that is something that you are going to do in my model. So yes, so here we have, they are automated 24/7 warehouse. This is just an example of how forecasting is making this factory actually efficient, and what they use is primarily historical data, trends, and buyer financial experience to set financial and operating plans using software. Excel in this case is actually very, very simple. Here we have another example, demand forecasting, retail and wholesale demand forecasting software. So you can find this nice video in this website. I advise you to go and see these videos. It's examples about consulting companies. There are many consulting companies that probably will be one of your targets if you decide that this is what you like as an economist. There are many researchers, these research enterprises, public, private, as well, that would like to get forecasting or forecasters to join their lines. So the forecast analysts then provide the decision makers with forecasts for many of their areas, or like administrative areas. Yes, it is almost everywhere in all administrative area, finance, it can be in production, management, etc., etc. So we have that forecast can be cross-sectional or time series. Time series is when we have time, when all the data is like delivered in time, but also we can make forecasts with cross-sectional data. The cross-sectional data are more like pictures of certain time, certain period of time, if you want, sometimes. So it's not like a movie where we have several pictures moving and make allow us to see a video. So when we have infinite numbers, or like several pictures, like in emotion, we are able to see movies. Yes, so that is a time series actually. Our eyes do not perceive that there are several pictures, because the frames per second are probably 60 or 30 at least. So we cannot distinguish that it's actually pictures. So yes, so we have then that we have cross-sectional data that is just in one time versus time series. This is an example of the ridership of Amtrak trains. So this is an US railway company. We have here the data. This part is actually very important for you to understand. Time is t. Yt is the value of the time series in the period t. Yes, imagine that t is years. In this case, it's months, for instance, in this example. So you can see that this one is yt1. This one, let me see if I can use actually my pen very quickly, and my abilities here to use my pen just disappear. Oh no, it's here. behind my coffee. Yes. So let's go here to use this, and you can see that this one here is actually y. This is a y. Have faith on that y1. This one here is y2. This one here is y3, and so on so far. Yes. So as you can see, this is the notation that we are using, right? And we want is to forecast in the time t plus k. K is like the horizon that we want to use in order to forecast. So for instance, if we are in yt plus 3, the forecast can be in the horizon of let's say 5 months. So if k equal 5, yes, if k equal 5, so therefore what we are trying to look is at 3 plus 5 will be to, we will need to count 1, 2, 3, 4, 5. This one will be f t plus chi. So if we are standing here in y3, will be 3 plus 5. Yes, as you can see, 5 is k, so this one will be 3 plus 5, the eighth observation in this data set. That is what we wanted to forecast. The ET are the errors. Yes, so forecast error for period t. So errors are everywhere. Errors are when you, for instance, make a test and you have an error. Sometimes when you are boxing as well and you send your punch and you do not hit, there is an error that you can measure by the distance between your objective and your fist. And as you can see, errors are everywhere, and exactly the same in forecasting. You forecast something and you have the real reading. So you forecast GDP, right? And you have the actual reading. We have every time that they are sending us these fundamentals, so we have fundamental releases on internet, you have an estimate and the actual value. So you are able to calculate what was the error. Yes? So that is the notation. Very important. Remember this notation because we are going to use these letters from now on. I will be refreshing this later on, so do not worry. So, yes, so is the goal descriptive or predictive? So we are trying, if you are trying to describe, you can use time series analysis. If you want to predict, we are going to do this. We use this module, which is time series forecasting. Well, in general, because we want as well to make robots to automate, so we are going to use data from Refinitiv and Bloomberg. Let's see if we can include Bloomberg as well in this academic year. So we have this forecasting process: define goal, get data, explore and visualize a series, and you can see all the process, and you can see how sometimes we do not carry on going down in this process. We sometimes we apply forecast methods, we evaluate, we carry on applying forecasting methods, and we carry on in this cycle up until something nice come up. Yes, you are forecasting, let's say, gold or Bitcoin. You carry on applying forecasting methods, you evaluate the performance of that forecasting method, not good, you use a different one. Oh, you find something really, really, really good, so you implement the forecast system. So the first one is the goal definition, and is something that we are going to cover very quickly here. So what you need to do first is to state what is the forecast horizon. That is something that you will need to decide for your assessments, for instance, and that is the letter K. What is this? What is K? Is the one of the main problems. If you are in a business, probably K is going to be given. If you are not, you can decide that by yourself. For instance, if you are doing your own investments. But in general, it's very important. Also, you will need to decide whether you are roll forward forecasting. Yes, so if you want to roll forward forecasting, is adding more data every time that a time continues, like uh, 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 like passing. So you will be able to carry on adding more data, and you will roll forward forecast. Say that you are forecasting any asset, let's say, or any equity, Tesla. So you have the data up until now, and tomorrow you carry on adding the data of tomorrow and the data of the next day and the next day. So you carry on roll forward forecasting. Sometimes, if you are hired by, for instance, Lesta Council, or I do not know if you have a role like as a researcher, you only are going to be able to need to forecast for only one time. So this implies that you need to get to know how much data is needed, the choice of forecasting methods, the expected levels of accuracy. Yes, what the accuracy, the expected levels of accuracy is. How accurate is your forecast? How is the performance, like in comparison with other forecasting methods and the model deployment? So you will need to get to know all these things. So also, how will the forecast are going to be used? So if you are working in a real life role in this, you will need some of these, the stakeholders, the numerical or event forecast, whether you have a numerical or an event forecast. So numerical is like a number, a figure. An event forecast is, for instance, if you have let's say, like a shock event, like the pandemic, yes. Let's say, like actually we are going to forecast, for instance, if we are going to have a lockdown in Christmas later on in this course, and well, I don't think that we are going to have a lockdown, of course, but I think we did this exercise the previous year, and it resulted to be very, very nice. So let's see what are the results for this year. Okay, forecasting expertise and automation, you need to get to know this if you are going to in-house forecasting, or if you are going to use consultants. You need to get to know how many series, how often, one-time forecasting or ongoing, where if you are going to get someone helping you with the data and the software availability, etc. This is then our introductory session for your week 2 session, and please um, um, perform the next activity. See you then in our online sessions.